Hello everyone, this is Kowshiq Kattamuri. So this is the part 3 video of STL problems for revision. So we have already covered part 1 and part 2 where we have discussed 8 problems and we are left with 5 more problems which includes the data structures, multi-set, map, unordered map, multi-map, and there's a last question related to next permutation. I hope I shall cover all these 5 problems in this video itself, no matter how much the duration would be, because we are just lagging behind. I don't want that to happen. And with these 3 videos, I think you people should get enough clarity about how to use a particular data structure, how do we iterate through it, how do we access the values, when and where do we use a particular data structures. All these things will be very very clear after you go through the part 1 STL, part 2 STL problem solving, and even the conceptual video. That is the very first video that I have uploaded in this introduction to data structures using C++ series. So this is the fourth video and third part for the problems for revision. I may take another part for this, like where I would explain the concepts of a lambda function, where we the other words is like custom operator, where we design a particular functionality for our purpose and use it for a particular STL. All right, so we'll discuss that in the maybe next playlist, next video. All right, so let us go to the very first question. Like this 5 problems, in this 5 problems, the first question comes out to be squares of a sorted array, so which includes the data structure multi-set. Telling you this once again, like multi-site is not very used, because like many of the problems that we do in DSA does not include multi-site. But some purposes, if we wanted to make our work easy, we use multi-site. All right, but we do not counter many problems which actually involve the use of multi-site. All right, so this is the very first problem. So squares of a sorted array, this is the question. So given an integer array nums sorted in non-decreasing order. So what does non-decreasing order mean? Non-decreasing order. So as the name says, it is like non-decreasing order. That means the things are like ascending. Okay, non-descending order in the sense it is ascending, but there might be values such that they both might be equal. Like for example, 1, 1, 2, 3. I can call this as a non-decreasing order. I cannot call this as an increasing order because 1 and 1 both are equal. I cannot say 1 is greater than 1, right? So these are like there are elements that are equal. So that is the reason we consider it as a non-decreasing order. It has a non-decreasing order. So the values would be in an increasing order, but some elements would be like both are same, both are like an equal in value. So that is the reason we term it as a non-decreasing order. So it's very very important. Like some of you people might not be aware of this, but yeah. Return an array of the squares of each number sorted in non-decreasing order as well. So if I would give you this as a nums, the result of this would be 1, 1, 4, 9. All right, so because 1 square is 1, 1 square is 1 again, 2 square is 4, 3 square is 9. This is a non-decreasing order as well because 1 is equal to 1. So we must return this as the answer. So that is the question. So if you go through the input, the first example one, the nums has been given to us as -4, -1, 0, 3, 10. So what would be the answer for it? It would be 16. Generally, I'm just putting the values of their respective squares: 16, 1, 0, 900. And what are we expected to return as an answer? 0, 1, 9, 1600. So this is what the required answer is. All right, required answer. This is what the question is actually expecting us to return. So it's like we are arranging them in a non-decreasing order. So given the example to -7, -3, 2, 3, 11, 4, 9, 9, 49, 120. So what is the best data structure to use in this case? Undoubtedly, it is a set. All right, I'll come to the reason why multi-set is preferred, not a set. So let us write set. So what are the functionalities of a set? It arranges in an increasing order. All right, increasing order. Second one, uniqueness is maintained. All right, uniqueness is maintained. So both of the things are maintained in a set, uniqueness. So there are no duplicates, no place for duplicates, no place for duplicates. That is very very important. So no place for duplicates. Now let us assume we are using a set to store these values. So once we are using a set, as you keep inserting the values, all of them would be arranged in an increasing order. All right, so let us assume this is a set that I've taken. So once I've inserted -4, so the value at that instance would be 16 and it will be stored at the very beginning. When I insert -1, so once I insert -1, like the square of -1, that would be 1. All right, when I insert that, now because 1 is less than 16, so it will be arranged at the very first place before 16. All right, so it would be in this case we have just inserted the values till this point. All right, now we are inserting 0, the square of 0, that is 0. So now 0 is less than these two values, so it will come to the beginning of the set. So it would be 0, 1, 16. Now when you try to insert the square of 3, that is 9, into this set, now because 9 is greater than 1 and less than 16, 9 would come and place in between 16. So this would be the like case of the set till now. And now when you insert the square of 10, that is 100, because 100 is greater than all elements that are present right now in the set, it would come to the end. So yeah, this would be the answer. Fine. So this is what even the question is actually expecting us to return in this case. Now let us assume we are doing it for this values. All right, second example. What is the second example? Num is equal to -7, -3, 2, 3, 11. Okay, now the set, let us take the set. So as you enter -7 square, that is 49, so it would be in this case, like it will be at the very initial position of the set. Now when you insert the square of -3, that is 9. So because 9 is less than 49, it would arrange itself to the beginning, before, to the left of 49. All right, 9 and 49. When you insert square of 2, that is 4, because 4 is less than 9, it will insert to the left of 9. So it would be like 4, 9, 49. Now when you insert 3 square again, so it would be 9. Now because 9 is already present in the set, it will not make any changes, rather it will be just the same, like 4, 9, 49. There will be no more addition of 9 in the set, because set maintains the uniqueness. Now when you insert 11 square, that is 121, because 121 is greater than all the values that are present right now in the set, so it will be inserted at the end. So this would be the answer: 4, 9, 49, 121. But what is question expecting us to return? 499. So there must be two nines. All right, but our set is only inserting one 9, it's not inserting any other nines, so this would not be the required answer. This is not the required answer. So of course it would be a wrong answer. So for that reason we are using a multi-set. So I hope you remembered, have gone through the lectures of the very first lecture. I clearly explained what is the functionality of a multi-set. All right, multi-set. So multi-set is like it can store different values. All right, so the only difference between a set and a multi-set is there is no place for unique, like there is like I don't say no place for uniqueness, like um, no uniqueness factor is followed. All right, no uniqueness factor is followed. So it is not like only unique elements will be present in the set. It's not the case. Like even if there are same elements, it can be presented in the set. And the second functionality is it retains the properties, first property, like increasing order. All right, the set puts the elements in an increasing order, multi-set. All right, so that is the similarity between a set and multi-set. That is, they put the elements in an increasing order, and the differences in the set, uniqueness is maintained. Coming to multi-set, no uniqueness factor is followed. So for that reason, let us go through the code first. Multi-set int cow. So what is int? We are declaring that multi-set, our required multi-set, will carry the values which are of data type int. So it will take the values of int. And what are we naming it as? Cow. So for auto I of nums, so I hope you know this conventional like usage, like for each loop. For each loop, if you would have gone through the very first lecture, so this is what I've explained for each loop. So for auto I of nums, so that means for every element in the nums. So let us take the very second example. Second example is like clear difference between multi-set and set. It demonstrates it: -7, -3, 2, 3, 11. So when we use this convention for auto I in nums, so I first is -7, I would be equal to -7, and then it would be equal to -3, and then it would be equal to 2, and then it would be equal to 3, and then it would be equal to 11. So this is the values of I. All right, I is directly pointing out to the values, not the indexes. So for auto I of nums till the end of the nums, cow dot insert of pow I comma 2. So what is pow? Pow in the sense p w of ab denotes b a power sorry power of a comma b denotes the very first element a to the power of b. All right, so a power b. So power of I comma 2 denotes I square. All right, I square, because the second element is will be raised to the power and I would be the base. So power of a comma b is a comma b, a power b. So power of I comma 2 would be I square, I power 2. So you're inserting the power of 2 of every element into the set, that is square of each and every element to the set. So as soon as you keep entering the elements, we have seen the clear demonstration in the before slide, previous slide. So it rearranges the values in an ascending order, that means non-decreasing order. And then you can just copy all those elements into a result vector, vector int result cow dot begin cow dot end. So what does cow dot begin? That ending with the beginning of the set, the beginning of the multi set, cow dot end the next of the end of the set. So if I assume cow is equal to, so what would be the final answer of this nums? So 2 square 4 minus 3 square 9, 3 square 9, 7 square 49, 11 square 121. All right, so this is the final set, and now all these values will be copied into a vector. All right, into a vector named result, res. So vector int result, when you use this convention, that means cow dot begin cow dot end. So cow dot begin points to this value, cow dot end begin points to this value. All right, so it's like an inclusion exclusion principle. You're including this but you're excluding this. Till this point we are inserting all the elements that are there in the set to the vector. We are copying all those. So cow dot begin no, comma cow dot end copies all the elements into the res vector, and we are returning the vector final, because they do not want us to return a set, rather they want us to return a vector, because that is the reason the function is defined as vector int. So that is the main reason we are copying the elements of a set into a vector. If they would have asked a multi-map itself, we would have written multi-set itself, we would have written this cow itself. All right, we need not copy and do all those things. So let us first run this code. And yes, it worked. Now let us submit it. Yes, it worked. All right, so this is the usage of multi-set. I hope you have gotten enough clarity. So if there is any disturbance in understanding it, please rewatch the video again. It would help you further. So we are done with this question of multi-set. Now let us go to the next question, that is map, which deals the data structures of map. So moving on to the next problem, we have this problem: reduction operations to make the array elements equal. And the data structure that we're gonna use here is map, and we're gonna use all this STL r dot begin dot r begin, and we have some other thing like next. We have dot arrays, so we'll be seeing all these things here. So this is the question. So reduction operations to make the array elements equal. Let us first go through the question. Given an integer array nums, your goal is to make all the elements in nums equal. All right. So there will be a nums given to us. You must make all the elements in those nums equal, and there will be some procedure to follow to make this condition satisfied. To complete one operation, follow these steps. So what are those? Find the largest value in nums. All right, your very first task could be to find the largest value in the nums. Let it index be, let its index be I, zero index nums. All right, so zero index nums in the sense your indexing starts from zero in the nums. So 0 1 2, so in that way it begins. So let its index be I. So let the highest index, like highest value, largest value that you found in the nums array, let its index be I and its value be largest. If there are multiple elements with the largest value, pick the smallest I. So let us first take one nums. So nums would be, in my case, 7 8 4 8 2 6 9 8 9. All right, so this is my nums I've considered. And now what is the largest element in this nums? 9. But how many times it is actually there? 2 times. All right, what is the index of this? So this is 0 1 2 3 4 5 6 7, and this is 8. So there are two nines. So what index we gonna choose? is the least value index. So smallest type. So out of 6 and 8, which is the smallest? So 6. This is what we're gonna choose, and this is our I. And what is the largest? Largest is equal to 9. Find the next largest value in nums strictly smaller than largest. What do you mean by strictly smaller than the largest? That means strictly smaller in the sense this. It's not like less than or equal to. It must be this. All right. So what would be the next smallest element? Like next largest value. Next largest value. It would be 8. All right. Because just less than 9, it is just 8. 8, and we have three eights. Let its value be next largest. So in our case, the next largest value is 8. And now reduce nums I to next largest. So now your task is to make all these nines to eights. So when you make all those nines to eights, your number of eights would be now 5, because initially we have 3, and now you're transforming all the nines. How many nines are there? 2 nines. So when you transform all those nines to 8, so there'll be 2 more additions of it. Total 5 eights will be there. So return the number of operations to make all elements and nums equal. So basically, what are they saying? We must equate all of them to the least possible value present in the nums. So in our case, the least possible value that is present is 2. So how do we go? First, we transform all nines into eights, and then we transform all eights into like eights new plus eights that are there in old, like previously what we have. So converting all them into the next smallest element. What is the next smallest element? That is 7. So we convert 7. And now new number of sevens plus old number of sevens, converting all of them into what is the next smallest element we have? 6. So 6. And then 6 new plus 6 old. So what's the next smallest element that we have? 4. So we convert into 4. And then 4 new plus 4 old, we convert all of them into the next smallest element, that is 2. 2. All right. So we'll be converting finally after this operations will be the required nums would be 2 2 2 2 2 2 2. All right. So yeah, how many twos? 8, right? 8 elements are there in our nums initially. So 4, and yeah, extra 4 2 we need to add. So this is the case. So this would be the final answer. I hope you understood it. So how do we proceed? To be honest, the whole solution, the whole idea has been given in the question itself. So we just need to use a proper data structure to implement this process. So that is the reason we need to have a very good knowledge about the data structures. We can use it to the required purpose. It's not like you're gonna use any sort of data structures to solve this question. There's a particular data structure that can be very useful, and it can actually give you the right purpose. Like it can be a right full data structure to your purpose. So what is it? Map. So why are we choosing map? Let us first go through the map. Actually, map. So map, what is the functionalities of map? First thing, it ensures the increasing order, right? In increasing order, it arranges its elements. Second thing, what it does is like it can store the second variable that you're tracking. For most often, it would be the frequency. All right, frequency. You can store the frequency. You can store the frequency of a particular element. So map is used to store the elements in an increasing order, as well as store the frequency of that particular element. So if, for example, let us take this nums. So if I have a map named MP, all right. So when I iterate through this nums and I store the values of them in the map, then what would I have? Map of 2 would be 1, because there is only one element in the nums. Map of 4, mp of 4, what would that be? There's only one 4, so it would be 1. MP of 6, how many 6s are there? Only 1. MP of 7, how many 7s are there? Only 1. MP of 8, how many 8s are there? Just 3. MP of 9, how many 9s are there? 2. All right. And other elements, MP of 0, MP of 1, MP of 3, MP of 5, MP of 10, any other element, it will be 0, because there's no existence of that particular element in our map MP. So this is how it stores, and it stores in an increasing order. So how does it store this value? So it goes on storing in an increasing order, from starting from the 2, 4, 6, 7, 8, 9. All right. So that is a functionality of a map. If you need some particular increasing order or decreasing order, it would be preferential for you to use set, all right. And if you want the uniqueness to be maintained, you can use a set. Right now we want the elements to be in an increasing order. Why do we need to have them in an increasing order? I'll explain it. But besides that, we also need to have an idea about how many elements are there, how many particular elements are there. Because to convert 9 into 8, we need two operations. Why? Reason being, there are two nines, all right. There are two nines in our nums, so we need to convert each 9 to 8. So how many nines are there? Two nines, so we need quite two operations. So that is the reason we are maintaining a counter to each and every element. And now when we actually transform 9 to 8, so there will be two more 8s. Previously there are three, and now addition to it, two more 8s are there, because we have converted 9s to 8s. Now there are total number of 5 8s. All right, 5 8s are there. And now we'll convert all the 5 8s to 7. So how many operations would it take? 5 operations. Because to convert each 8 to 7, we need one operation. There are total of 5 8, so we need five operations. And initially we have 1 7, and now we have new 7s to be 5. So 5 plus 1, 6 operations we need. And initially we had 1 6, and two new 6s, we have 6. Totally we need 7 operations. And now when we have this 4 old, we have only 1 4. And because now 7 4s are being there, because 6 in total, 7 6s have been converted to the 4, so we have 7 4s here. So 7 4 plus 1 4, 8 operations total. So that is the reason the answer would be like output equals to 3. Yeah, because in this case, like, this is a different terms. So what is this example is 5 1 3. All right, 5 1 3. Firstly, we'll look at to the highest largest value, that is 5. So 5 gets converted to 3 in one operation, and now the nums would be 3 1 3. And now there are two threes, so two threes gets converted to the next the smallest element, that is 1. So here we require two operations. So now the nums would be 1 1 1, and now all the elements are equal. All the elements are equal. So the total operations are 3. All right. So that is the reason answer is 3. Output is 3. I hope you understood it. Now let us go through the code. So first we'll be having a map which has int comma int. Why int comma int? Because it is the data type we are storing. We are all the numbers of the nums are int, vector int. So all the nums are int, and the frequency of those also will be int. And now for auto I of nums, we are pushing all elements to the map. So cow of I plus plus. What do you mean by cow of I plus is? To that particular element, we are increasing the frequency by 1. So cow of, when we encounter 5, all right, when we let us go to the next page and take this example. So 5 1 3, 5 1 3. So when we start pushing cow to 5 to the cow of 5 is initially 0, and now when we do plus plus, it would be equal to 1. All right, and when we add 1, cow of 1 would be 1. When we add 3, cow of 3 would be 1. All right, so we have increased the counter to each and every element. And now initially answer is equal to 0. That is the answer, that is the number of operations. So while cow dot size is greater than 1, all right, till we are exploring all the elements of the cow of the map, we will be doing these operations. Once our map would be empty, there is no more element in the map, we'll be stopping the operations, and we'll be returning the final answer. So int val1, cow dot r begin of first. So what does this mean? Now when we insert this into the map, so how does that get stored? 5 comma 1, 1 comma 1, sorry, order is maintained, right? So how will that be stored? 1 comma 1, 3 comma 1, 5 comma 1. What does this mean? There is only one instance of 1, there is only one instance of 3, there is only one instance of 5 in the map. So this is our map. Now in this map, cow dot r begin. So begin in the sense this would be there. R begin in the sense at the end. All right, at the end. So R begin points to the end, exact end of our map. And in that we are accessing the first element. So what is the first element? This is the first element. This is what we are accessing. Now what is value to next? Next in the sense here, because we are pointing to r cow dot r begin. See here, cow dot r begin. So when you apply next to it, it would come to this way. All right, come to this way, because you are doing it in a reverse order. R begin in the sense reverse of begin. So when you apply next to it, you would come to this pointer. All right, so when you come to this pointer again, here you are accessing the first element. That means we are accessing 3. So we are accessing 3 here, that we have stored in val2. Here we have accessed 5, and we have stored it in val1. Now what are we doing? Answer plus equal to cow of val1. Why are we adding cow of val1 as an answer? Because we are converting all 5s to 3s. So how many operations are being required here? That frequency of 5, because there is only one 5 here, we need only one operation. It would have been some 3 or 4, we would have been required 3 or 4 operations to convert all 5s into 3. So that is the reason we are adding cow of 5 to our answer. And once we add it, we will also update a cow of value 2 with cow of value 1, because once you convert 5 to 3, your number of threes would be now 2, right? Because initially there is one 5, we have converted that to 3, so there's an addition of one 5 being converted to 3, so there are now two threes. Initially one we have, and now we have converted one 5 to 3, so addition of one 3, so there are two threes. So that is the reason cow of val 2, we are updating it, we are adding cow of val 1 to it. Cow of val 1 in the sense, the largest value frequency we are adding to the next largest value frequency. And now we are erasing it. Now we are erasing this element. We no longer require this 5, because 5 is no more there. We have converted all the 5s to 3, so in the map we don't need it. So that is the reason we are erasing. Because we are erasing, at some instance we'll have the map to be empty, and that means when it is empty, we are done with our problem, we have solved it. So that is the reason it goes on. So this is the pure logic that has been stated in the question itself. We are just implementing it with the use of map. So in value 1 we have stored the largest value, in value 2 we have stored the next largest value, and we are adding answer as the largest value frequency, and then we are when updating its frequency with this frequency by adding this frequency, because all these values have been converted into this. And this goes on. Once we are done, will be removing it, and now again this point, the next value points out here, the largest value points out here, again the same process goes on. This goes on till our cow dot size is greater than 1. That means till our map becomes empty. So we'll be doing it, and finally we'll be returning the answer. So let us now run the code. It must work. Yeah, it worked. So let us now submit it. Yeah, it worked. So I hope you people have understood. So this might not be an optimal solution, but we are trying to use the data structures that we have learned so far. We are trying to implement them. We are looking and how are we using it. So all those things, that is the reason. Fine. So it's not like I am putting the optimal solution here. No, there might be very good solutions out there, but we are only seeing the perfect usage of our data structures that we have learned so far. So I hope it's clear. And at any point again, if you did not understand the logic, please watch the video once again, go through the question carefully. It would help you in understanding the problem much more in clear fashion. All right, so we are done with this problem. We'll just tick it and we'll go to the next problem. So coming to the next question, this question is contains duplicates too. So this deals with the data structures unordered map. So, and we'll be using dot find STL here. Like that is a particular STL that we're going to use in this unordered map for solving this question. So this is the question. So contains duplicates too. Let us first go through the question. Given an integer array nums, all right, given an integer array nums and an integer k, return true if there are two distinct indices I and j, and the array says that nums of I is actually equal to nums of j. That means at that particular two distinct indices there are same element present. There is a same element present. So and absolute value of abs denotes the absolute value. So abs denotes absolute value. So absolute value, so I hope you people know what is absolute value is. So abs of -1 is equal to 1, abs of positive numbers remains the same, that is 1. So that is what they actually mean by abs. And abs of I minus j is less than or equal to k. What do they mean actually? So irrespective of the like elements comparison between I and j, I might be greater than j or I might be less than j, okay, but they shouldn't be equal because they are distinct. They must be distinct indices, and they can be anything, like one can be greater than the other, one can be less than the other, not a problem, but the absolute value of the difference between them must be less than or equal to k. That is what they're actually wanting, like that is the condition they want us to satisfy. So let us go through the very first example. So nums that has been given to us is 1 2 3 1. All right, so very first thing that we need to say is nums of I is equal to nums of j. So we can find that here 1 is actually equal to 1, and the indices are here, the index is 0, here the index is 1, sorry 4, 0 1 2 3, sorry, 0 1 2 3. So this is 1, this is 2, and this is 3. So 0 and 3. So this can be I, this can be j, or this can be j, this can be I, not a problem. But the absolute value of the difference between these two, so what is the value of abs of 0 minus 3, and this can be also be like abs of 3 minus 0, this both are equal to 3, and that must be less than or equal to 3 because k is actually 3. All right, so yes, we're gonna return a true in this scenario. All right, in this situation we're gonna return a true. Come to example 2, we can find that 1 1 1, there are three ones here, and you need to return like true even if you find anything like one case where it's less than or equal to k. All right, so take 1 0 1 1. So the index in this case is 0, here it is 1, here it is 2. All right, so 1 minus 0 or 0 minus 1, like take the absolute, this both would be equal to 1, and less than, that is less than or equal to 1. All right, so now abs of, take these two, that is 0 minus 2 or 2 minus 0, that both will result in 2, but that is not less than 1. But it's fine, it's not less than or equal to 1, but it is fine because we have already found one pair which is resulting in the required condition. So we're gonna return true in this scenario. All right, it's not required that all of them must be satisfying. No, even if one satisfies, that is enough, we'll be returning true. Come to the third example where like this case it gives a false. Why? 1 2 3 1 2 3. Now there are several elements that are equal, so let us first consider 1 and 1. Here we have the index to be 0 1 2 3 4 and 5. All right, now the k has been given to us 2. Let us now consider 1. All right, if 1, we have the other index to be 3, so absolute value of 3 minus 0 or absolute value of 0 minus 3 both will result in 3, and that is not less than or equal to 2. So this fails. Come to case of 2. So 2 absolute value of, so 1 and 4, so 1 minus 4, and that is actually equal to 4 minus 1, and that is also 3, and that is also not less than or equal to 2. So case fails with 2, case fails with 1. Now come to case of 3, that is 2 5, same thing happens, that is also gonna fail. So we cannot have any pair, any single pair that satisfies this condition, so in total we will be returning false. So why are we using an unordered map here? First, there is no involvement of the order. So like there's main difference between map and an unordered map. Unordered map, what is the main difference? Order. All right, in an unordered map, order is not maintained, order is not maintained, but in a map, order is maintained. So in our case, we don't involve the factor of order, right? Order is not considered, there is no importance to order, so that is the reason we use an unordered map. All right, so that is the main thing. Now let us go through the code. First of all, we have declared unordered map that is of int comma int because the nums is of type int, and the frequency, in this case we are not storing frequency. All right, so what are we storing? We are storing cow of nums of I equal to I. So we'll go through it. So that is what I've told in the previous problem, that you can store anything, like you can store its frequency. More often we'll be storing its frequency, but in this case we'll be storing the index, the latest index that we are encountering to that particular element. Let us see that in brief way. Let us first go through the code. So int comma int, so that is, and the name of the unordered map is cow. Now let us first go through the array for int I equal to 0, I less than num start size I plus plus. So what are we trying to do? Let us now take the very first example, or maybe, yeah, first example is good. So 1 2 3 1. Now once we go into this, we'll be checking in our map, unordered map. So what did we name our unordered map to be? Cow. So now I'll check, is cow of one like, do we have one in our unordered map? So I'll be checking it. So that is what I'm doing. If cow dot find of nums of I not equal to cow dot end, what does that mean? So you're not pointing to the next of the end of your cow. That means if your find is not pointing to the address of, let us assume this is our map, and if our find is not pointing to this address, not pointing to this address, that means there is some instance of one in our map. If it is pointing to the next of the end of our map, that means there is no one in this map, because that is the reason it's pointing next to the end. If it would have pointed somewhere in between the map, that means we can assume that there is one case, there is some case of scenario of one in our map, but there's no one in our map. That is the reason it's pointing to the next of the end. So if it is not pointing, all right, if it is not pointing, that means we have 1 already in our map, and I minus cow of nums of I less than or equal to k. Let us leave this condition as of now. So because this condition is failing, it is like end, it is not or, it is end. That means each and every condition must work. So because this condition is failing, we'll not go into the f, and we'll just follow the last statement, that is cow of nums of I equal to I. So that is cow of 1, I'm feeding it as the index. So what is the index? 0. All right, we are initially at index 0. So cow of 1 nums of I, that's nums of 0, that is 1, and that I'm saving it as 0. Now come to 2. Again the same case, we did not find 2 in the map because we have not inserted 2 yet, we have only inserted 1. So and that the value to that corresponding one we have kept it as 0. So there is no 2, so we'll not go into the if loop. Now we'll directly go to the last statement, that is cow of nums of I, that is 2, equal to the index of it. So 2 will be storing in the map, corresponding to that we'll keep the value as 1. Come to 3. All right, now come to 3. Again 3 is, we do not find 3, we do not find 3 in our cow unordered map, so we'll putting 3, and corresponding to that we'll be storing its index. Now come to the 1 again, we'll be coming to 1 again. Now your cow dot find will not point to this, because we have 1 in our map, so it will point to this address. All right, it will point to this address. And now I minus cow of nums of I, so I is your present index. What is that? 3. And what is the previous thing that we have stored for cow of 1? That is last index that we have encountered for 1, that is 0. So we are checking if the absolute value of this, so I forgot to mention abs for this. Of course you need not mention abs, because your I would be anyways greater, because you're iterating I in this fashion, so you need not check it. So 3 minus cow of nums of I, that is cow of 0, cow of 1. So what is cow of 1? That is 0. All right, because corresponding to 1 in the unordered map we have stored 0. So 3 minus 0, is that less than or equal to k? What is k in our case? It is 3. So yes, it is less than or equal to 3. Return true. That's it, we are done. We don't need to check for any other thing. Once we find anything like that, we'll be returning true. So we'll be returning true, and that's it, we are done with that problem. I hope you understood it. So we are storing that particular index every time we encounter a particular element. So once we encounter the same element again, we'll be subtracting the previously encountered, previously counted the same element, we have stored it particular corresponding index. So cow of 1 equal to 0, because 0 is a particular index when we have encountered 1 for the very first time. And now when we are encountering it again, we'll be seeing that its present index minus the previous index, that is 0, is less than or equal to k. So that's the reason we are returning true. So let us run this code. I hope you people understood it. What is the logic behind this? And yes, it worked. And let us now try to submit it. And it actually worked. All right. So this is so simple. I hope you understood it. If not, watch the video again. Go through the question carefully. Very, very simple. Just we have used the functionality of an unordered map dot find, and we are able to find that corresponding element in our map. If it is there, that means we have already stored the corresponding value of index to that particular value, and we are subtracting the present index we are at in the nums with the previously encountered index, and we are checking if that value is less than or equal to k or not. And if it is, we are returning true, nor we are storing the latest value again, right? So that is all for it. I hope you understood. So now let us go to the next problem. So coming to the next problem, that is k weakest rows in a matrix, and we'll be using the data structures multi-map, and the STL is like insert, begin, and end. All right. So moving forward to the question, so you're given an m cross n binary matrix, mat. So the matrix name is mat. So let me go to the next page. So mat of ones representing soldiers and zeros representing civilians. All right. So the soldiers are positioned in front of the civilians, that is all the ones will appear to the left of all the rows in each row. So first of all, you are given an m cross m binary matrix. Let us assume the m is 5 and n is 4. And now if that is the case, then that means there are 5 rows. All right. So 1 2 3 4, there are 5 rows and 4 columns. 1 2 3. And now there, it's been clearly stated that the soldiers are represented by 1, the soldiers are represented by 1, and civilians are represented by 0, and all ones appear to the left of 0. So if you find any 0 at any particular place, that means to the right of it all will be 0 itself, no need to check. and to the left of this zero, very first zero, everyone will be of ones, every grid will be one. To the right of a first zero, every grid will be zero. All right. A row I is weaker than a row J if one of the following is true. The number of soldiers in row I is less than the number of soldiers in row J. Alright, for example, let us assume there are two ones here, three ones here, only one here, four ones here, and zero ones here. That means there are two soldiers, three soldiers, one soldier, four soldier, zero soldier. So if row I is weaker than row J, if one of the following, any one of these following conditions. So if I compare this first row and I mean zeroth row and second row, okay, zeroth row and second row, my zeroth row will be stronger than second row. The reason being, here we have two soldiers, here there is only one soldier. So this row is weaker than zeroth row. All right, this is for sure. Both rows have the same number of soldiers and I is less than j. So there might be even a case like if I suppose write this as 2, all right, and if this is I and this is j, so my ith row that is 0, jth row that is what is that, and that is 4, sorry, 3, 0, 1, 2, 3. And because 0 is less than 3, and both of them eventually have the same number of soldiers, two soldiers and two soldiers, but here 0 is less than 3, that is the reason this is weaker. All right. So if there are two rows which are having the same soldiers, same number of soldiers, then compare their indices and come to a conclusion. If a particular row is having a less index value compared to the other row, that means that would be the weaker. Return the indices of the k weakest rows in the matrix ordered from weakest to strongest. So let us take the first example. So the first example, let us first make a grid. So how many rows are there? 5 rows and 5 columns. So firstly, we'll make a 5 row by 5 column matrix. 1, 2, 3, and 4. Yeah. And then again the same case, 1, 2, 3, 4. Now let us write the numbers. 1, 1, 0, 0, 0. 1, 1, 0, 0, 0. Second, 1, 1, 1, 1, 0. Third, 1, 0, 0, 0, 0. Fourth, 1, 1, 0, 0, 0. Fifth, 1, 1, 1, 1, 1, 1. That means here there are two soldiers, here four soldiers, here there is only one soldier, here there are two soldiers, here there are five soldiers. All right. Now let us order them in the weakest to strongest. Yeah, weakest to strongest. Let us order them now. Are there any zero soldiers anywhere? Uh, no, I don't think so. So yeah. So if I like corresponding to 2, there is an index of like, for let us now first maintain the counter. So the increasing order is there is only one soldier, there are two soldiers, there are rows with two soldiers, there is a single row with four soldiers, there is a single row with five soldiers. So corresponding to this, let us write the indices. So a row which having only one soldier, that is second row. A row which is having two soldiers, that is 0 and 4. Sorry, 3. This is 2, this is 1, this is 4. So 0 and 3. Corresponding to the counter of 4, 4 soldiers is present in one index, first index, and 5 soldiers are present in fourth index. So this is the indices, and from this you need to return the first 3, because your k is 3 here. So returning this first 3, we need to return these 3. All right. So that is the reason the answer is 203. I hope you got it. So this is how you need to do it. First, maintain the counter array. Like here, the counter array in the sense there are rows with one. There is a single row with only one soldier. There are two rows with two soldiers. There is only single row with four soldiers. There is only a single row with five soldiers. And corresponding to that, write the indexes. All right, and return the first k. If it is 3, return first 3. If it is 4, return first 4. That's it. I hope we'll be similarly solving it example 2. Then come to the like data structure. Why are we using a multi-map here? So what is the difference between a multi-map and a map? Multi-map and a map. All right. Only difference is the keys, the values that you're storing, okay, need not be 1 1, need not be 1 1. That means in a map, for a single value of like the input, you are storing a single value of corresponding thing. Either it may be a frequency, it may be index, anything. Only one thing is stored. But in multi-map, for a corresponding key, you can store multiple values. You can store multiple values. All right, you can store multiple values. But in map, you can only store a single value corresponding to a single key. All right, that is only difference. Increasing order maintains the same. Like multi-map also maintains the increasing order, map also maintains the increasing order. That is the similarity. Coming to the difference, map only stores one parameter to the one particular element or key, but in a multi-map you can store various things. So we'll see that here. Firstly, we'll be declaring a multi-map of type int comma int, and then we are declaring a vector, that is answer, because we eventually need to return a vector. And int number equal to 0, what does that mean? So we'll see that for int I equal to 0, I less than mat dot size I plus plus. So what is the mat? That is the 2D vector that has been given to us. And number, we are saving it as, we are equating it to count of mat of I dot begin, mat of I dot end comma 1. What does this mean? Count of mat of I dot begin. What is mat of I? It is a vector again. All right, because mat is a 2D vector, so each and every grid of mat will store a particular vector, and for that particular vector we can have begin, we can have end, all those things. So mat of I dot begin, mat of I dot begin, mat of I dot end, mat of I dot end, and 1. So what does the count of 1 do? In this particular vector, mat of I vector, it will return the count of ones that are there in it. So we eventually need it because we need to find the counter of soldiers particular found in that particular row. So in this particular row, we have mat of I as a vector, and from the beginning of that vector to the end of that vector, we are finding the count of 1, like number of ones that are present, and that we are equating to number, and we are, and this number we are using it as a key. All right, key in our map. So for a particular number, we'll be storing all its appearances in that, in various indexes. So this particular number of soldiers can appear in second row, fourth row, seventh row, it might be any row. So for all those rows will be uh, allocated to this particular key, that is number. All right, so dot in place of number comma I represents that to that particular number. So mp of number has all these integers stored, 247. All right, this is a normal example. So in our case, in our scenario, what is it? So 2, okay, 2 is the number. So initially mp of 2 will have only its particular index, so 0. And now when you go to the next row, you find that number of soldiers to be 4. So corresponding to 4, you'll be storing 1 because it's in the first index, so mp of 4 is 1. And now coming to second index, we have 1 soldier, so corresponding to 1 soldier will be storing its particular index, that is 2. And now again mp of 2. Why 2? Because in third row, in the fourth row, we have 2 soldiers, and now already 2 is there. So mp of 2 now would be 3. All right, so mp of 2 will have total of 2 values, 0 and 3. And now coming to the last row, mp of 5. So 5 is the number of soldiers. For 5, corresponding to that, store its particular index, that is 4. That's it. And now we'll be going through the map. And if k is greater than 0, why k is greater than 0? As we are entering the new value, so it in map, auto it in map, that is mp. So particular address, we have two values, the key, all right, key and particular value. All right, so that is, this is it dot first, this is it dot first, this is it dot second. So we are inserting this it dot second into the vector answer, and as we are entering it, we are reducing by k by 1, because we only need k number of elements. All right, so as we are entering it, we are reducing the count of k by 1. So at last will be remained with k equal to 0. That means the work is done, and we'll be breaking out of the loop and we'll be returning the answer. All right, so what are we inserting? It dot second. What is it dot second? The particular row. All right, the particular row, because your map already puts it in an increasing order, your arranges your key in an increasing order. What is your key? Number of soldiers. So one soldier is the least value, so for that particular value we have particular key, the value that is there is 2, and we have inserted this into the answer. Okay, now your answer vector will be having 2. And now when you go to the next part, 2 comma 2, for 2 comma 2 we have 0 and 3, we'll be inserting 0 and 3, we'll be reducing k 1 and 1. So now at this particular time k would be 0. All right, else we have put an else, that means else in the sense k is not greater than 0, k is some other value but it's not greater than 0. So we'll be breaking out, we don't need anything else, we'll be writing just this. So that is the reason your answer would be here 203. I hope you understood it, right? So we need only k elements from the beginning, and we are doing it, we are storing it in the unordered multi-map. So multi-map is helpful in this manner. So no matter how many values corresponding to that particular key is there, it will store all of them, and it will finally return as per your conditions. All right, so that is how it stores. I hope you have got enough clarity, and let us now run this code. Yes, it worked, and we'll even submit it. So before that, I just want you people to understand what are we doing here. It dot second, it dot second in the sense we have this map here. It points to that address, particular address. In that particular address, we have two values. First, that is the key. Okay, that is the key. Second, that is the value. So in a multi-map, there can be multiple values associated to that particular key. So your IT will point to each and every one of them. All right, each and every one of them. So how will it store? So for particular number of two, all right. So particular number of two, where is two here? So yeah, so number of soldiers are two. So how will it store? It will store like this particular for that example. So your map will be in this manner. So 1 comma 0, 2 comma what are the rows there for the two number of soldiers? 0. So 2 comma and 1 sorry, 2 is there in the third row, so 2 comma 3, and then 4 soldiers are present in one first row, 4 comma 1, and 5 soldiers are present in fourth row, so 5 comma 4. This is how your multi-map will look. First it would be here. For that it, you are taking the second element. All right, you're pushing out the you're pushing in the second element, right? You're pushing in the second, because this is the row that we are actually interested in. All right, this is the row we are actually interested in, so we are pushing this, and then we are pushing I have written the wrong answer. For the one soldier, we have two. All right. So for the one number of soldier is present in second row, so we will be pushing this. And now coming to this IT, for this IT second, we'll be pushing it, and then coming to this, we'll be pushing this IT dot second, and after this, your k would be 0, so you'll not be pushing any more elements. All right. I hope you have got enough clarity. If not, watch the video once again. I'm sure you'll understand what is happening. Also go through the question carefully. It's not like a rocket science thing in this question, very very easy. So yeah, it worked out, and yeah, we have successfully solved this question, and we are left with last question, and we'll see that right now. So coming to the last question, next permutation. All right, so this is the question. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, if array equal to 1 2 3, the following are all the permutations of 1 2 3. So first 1 3 2, 2 1 3, 2 3 1, 3 1 2, 3 2 1. All right. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. More formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. If such arrangement is not possible, the array must be arranged as the lowest possible order, that is sorted in increasing order. For example, the next permutation of arrays 1 2 3 is 1 3 2. So what are they actually trying to say? If I give you some numbers 1 7 4 8 9 3, all right, if I give you this as a array of numbers, so if I say what would be the next permutation of this, so what would you do is, firstly you will actually try to put them in an ascending order. All right, so when you try to put them in an ascending order, what would you get? 1 3 4 7 8 9. And from now your next permutation begins. What is the next greater than next number that can be formed? What's the just greater than number that can be formed from this number using after this number using the digits of this particular number? 1 3 4 7 8 9. What is the next number that can be formed? 1 3 4 7 9 8, right? Because the number that is just greater than this number is this, and this number should be made by the digits of this number. All right, that is what the condition is. That is the next permutation, that is next greater than number that you can make out of your digits that are present in your present number. So out of 1 3 4 7 8 9, the next number that you can make that is just greater than 1 3 4 7 8 9 is 1 3 4 7 9 8. All right, and now what is the next number greater number that you can make? 1 3, 4, 8, 7, 9. All right, this is what you can make the next greater number. What is the next greater number? 1, 3, 4, 8, 9, 7. I hope you understood it. So this is how you can make the next permutation. All right. So from that particular instance, how are you going forward? How are you moving forward? That is the main question. Nothing else. So coming to this basic example, 1, 2, 3. So in this particular example, 1, 2, 3. So the how can we write the next permutations of it? So the next permutations of it gonna be just a second, there is some glitch. Yeah, 1, 2, 3. It can be 1, 3, 2. All right, and the next thing could be 2, 1, 3, and the next thing could be 2, 3, 1. The next one could be 3, 1, 2, and the next one could be 3, 2, 1. All right, so these are the 6 permutations possible. You need to make sure at any particular instance, let us assume I'm giving you this, I must not written this. All right, I must not written this. My next permutation would be this, because they have clearly mentioned that must be lexicographically followed. So after this 1, 3, 2, the next permutation that is just greater than this is 2, 1, 3. This must be written. All right, that is the clear condition that has been given. I cannot written 1, 2, 3. All right, that is also permutation of 1, 3, 2, but I cannot written it because lexicographically it is smallest than 1, 3, 2. So I must written only that thing which is just greater than 1, 3, 2. That is 2, 1, 3. So that is the reason we are writing 213, and then 231. If it is given 213, we'll be writing 231. If it is given 231, we'll be writing 312. If we are given with 312, we'll be writing 321. If it is 321, that's it. We cannot do any more modification, right? There's no other string that can be, there cannot be any other array of numbers that can be found after this. So we'll be just returning this. So all these things can be done in place using the next permutation STL. All right, so next permutation is STL, where you'll be putting the nums dot begin, you're the beginning of the nums dot end, the end. All right, this is excluded. So nums dot begin comma nums dot end takes all the elements in this particular range, okay, from beginning to till the end. Okay, till the end part. So till this end part will be taking all the elements, and then it will do the next permutation. So if I give it 1, 2, 3, it will do the next permutation, and it will be modifying it as 1, 3, 2. And because it is a void, we need not return anything, just we need to do the modification, and it will take care of the rest. The program will do the rest. So it will do the things like 1, 2, 3 gets changed to 1, 3, 2. If I give 1, 3, 2, it will modify it as 2, 1, 3. All right, 2, 1, 3. But if I give it as 3, 2, 1, it will not do anything. It will just keep it as it is, and it will return the function. It will automatically do whatever it needs to do. So all this thing will be done through the next permutation STL. That is why it is really, really useful. There are plenty of lines of code that you need to write if you actually need to do it, but next permutation does that in a single line. You just need to pass it the range of the elements, and it will do it automatically. So that is the functionality of next permutation. So with this, we end our 15 problems, like 8 plus 5 13, sorry. So 13 problems we have completed. So I hope you have got good revision with all these problems. After going through all these problems carefully, all the videos that are being uploaded, including this video that will be uploaded right now, so you can get enough clarity of all the data structures. All right, how to use that particular data structure, like enough clarity that is required, prerequisite, and we'll be advancing it to each and every data structure later into the later parts of the video. So as of now, just get an introductory idea. How do we use it? Where do we use it? How do we iterate it? How do we actually access elements? All these things that are very, very important. Some data structures have exempted. It is left as a task for you people to find those particular questions, solve them. Okay, so I cannot help you in all the data structures. All right, because there are some easy data structures which we don't use, and you can easily find them in lead code. And so like articles that are mentioned, that is more than enough. Just go through the articles for that particular data structure I've exempted. All right, so yeah, that is for it. And coming to the assignment stuff, please do the assignment as soon as possible. Go through the videos, all the videos that I've uploaded. That will give you enough idea, enough clarity, and with that you can easily do the assignment and upload it before the deadline. So thank you for sparing your valuable time. And yes, we'll be moving forward with the next concepts, or might be I'll be taking another video for STL part 4, where I'll be taking one particular problem which relates with the lambda function. I'll explain it, and maybe I may upload it, I'm not sure, but yeah. Yes. So thank you for watching, and stay tuned.